So yeah, you took the leap into Netflix. So what was that like?
It was, this is one of those things where when you talk about it, people love to trivialize this because it's like, oh, you're taking a leap of faith by going into a FANG company in like 2013. Sounds super risky. My wife was 36 weeks pregnant. We had to travel to a place where we knew not a soul. We were about to have our first kid. We didn't even have a doctor. If you don't know, having a baby does you kind of want a relationship with a doctor. There's like a whole thing that goes on there. So it was a really hard and great experience. So I went to a job in which their culture deck. So during this time, this is where Netflix still had like kind of that old Generation X feel to it. Their culture deck was hire fast, fire fast. It was very in your face about like, hey, this is how we operate. You don't meet the standards, we kick you out. So it's like, I'm leaving a place where it's more secure to go to a place I don't know anybody, to a job that's bold in its claims about firing everybody, with a wife that's just about to have a baby. And so it's like, and I'm from Montana, and you're born, every Montanan's born with a natural dislike of California. So there's like all these things kind of flowing into it where it's just going to be like, wow, this is a very intense experience. And it was hard for sure. Like, it wasn't just some easy, simple experience that we were just like, oh, well, I work now at FANG. We had to kind of work through that. Having a kid was very difficult. Our first kid was very difficult. Not having any family around to ever help you. Like, it took a much larger toll on my wife than me, for sure.
What was the technical learning curve for you? You showed up in your plaid pants, like dressed up.
Yeah.
And what was it? What did you have to learn about the stack? Because Netflix, I imagine, is this incredible infrastructure that has to deliver just a huge amount of data. I'm just blown away by Netflix, but also like YouTube, these companies that have to deliver, like serve a huge amount of like bits.
Netflix has it easiest out of all the companies Netflix buy, even though you could say maybe we beat YouTube in view hours. I'm not sure if we do, but let's just pretend Netflix has 5x more view hours than YouTube. Whatever it is, Netflix has a fundamentally easier problem than all other companies. And let's get back to that. I'm going to first tell you about the stack, but I'll tell you why it has a fundamentally easier problem.
All right.
So when I first got there, they gave me my PlayStation 3. My boss said, go learn some code. Come back to me in a couple days and tell me what you've learned, and then I'm going to start giving you bugs to fix.
Wait. PlayStation 3, what are you talking about?
Well, I was on the TV team. I had to go plug in a PlayStation and start launching programs onto the PlayStation 3 and figure out how to work Netflix on a television device.
Oh, so like you have different kinds of devices. Why PlayStation 3? Is other different?
It's just 2013. That's
any
what
devices
you had.
that plug into the TV. Okay, cool.
Yeah, not as many TVs had Netflix, let alone what they called their Darwin app, which is their new application. Okay. So if you bought a Vizio earlier that year, you'd get their older one there. It's called Plus UI. You get their older version. And so not many had the newer version. We no longer supported Plus, or we never actively developed on Plus. We only did stuff on Darwin. And so I had to learn that whole stack. The back end, or the middle end, the middle layer between the actual back end and the front end was written in Groovy. And as I went around, Groovy is, if you're not familiar with Jenkins, then you've probably never interacted with Groovy. But Groovy is a JVM language. It's a very interesting language, but here's how it got started at Netflix.
Oh, it's Apache. Apache Groovy is a powerful object-oriented programming language that runs on the Java virtual machine, released in 2007. It has evolved to become a versatile language that combines both static and dynamic typing capabilities.
All right, so the AI is kind of lying to you. Groovy is not a powerful, great language. That statement makes it seem way cooler than it actually is. Mm-hmm. You will meet 1 out of 100 people that have touched Groovy that said, oh yeah, Groovy's great.
Yeah.
The other 99 will be like, heavens forbid you ever have to touch that language.
Yeah.
So when I got there, nobody, not a single soul at Netflix, there's 40-some engineers, had any idea how Groovy pretty much worked. Somehow people just hacked together these scripts and put them all on there, and it worked. And this was before there was a Groovy RX port. We wrote our own version called WX. It was a nightmare. Observables, all these things. I remember one time they told me that, oh yeah, with RX, it's really easy. You just say what you need to do. It maps out and boom, 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 boom. Everything will run multi-thread and all that. And I was like, oh wow, really? So all I did was go like observable.sleep1, because I just wanted to see it sleep and then do the next thing. And it turns out when a thread sleeps itself, no thread can wake it up. And I just turned off all of staging because I ran it like 10 times, like, oh, it's not responding. Oh, it's not responding. Oh, now it's not even coming back. Broke all of staging for everybody. So no developer could work for the rest of the afternoon because I locked up all the instances, because it turns out, no, it was in fact not multi-threaded. Every assumption we've been told is a lie. No one had any idea what they were doing. It was a wild time. And so I just simply naturally gravitated towards that because I'm good at printf debugging. I'm good at doing those things. So I was like, here, I'll just figure this out. Here, I will do this. So I had to rewrite how we do the data structure on the front end for the TV, from what is called a Lolomo, list of movies, into Loloromo, which is a list of recommendation objects for a movie. Why would we need to do that? Think about this. You have two lists. One has Live Free, Die Hard, Bruce Willis, because you love Bruce Willis. The other one has Live Free, Die Hard, because you want tough men doing tough jobs. Well, during those days, we'd only have one way we could show evidence why you wanted it. So we couldn't say, oh, because you liked this other movie. You'd go to that one and say the same thing. So we had to kind of add one level of indirection where we could decorate the video with the recommendation information.
Okay, so you can abstract away into the space of recommendation versus the space of movies directly.
Yeah, so you can't hang it off the video, because obviously then it would be the same for everything that shows that same video. So
that's amazing.
I had to do all this, and I wrote it in Groovy, and I just did it. And people were like, how did you write this in Groovy? And it's just like, well, I read the language reference for a day and then programmed it well. What do you mean? It was a very radical language, shall we say. And so I just simply became the person that knew these things. So they just give me more and more jobs at that. And so that's kind of how I excelled, being the person that was willing to do the thing that no one else was.
Yeah, can you actually speak to the printf debugging? Like you walk into a system, and there's a lot of systems in the world like this. Like Twitter was like this when Elon acquired Twitter, and then rolls in, and there's this old janky code base that's just like a giant mess, and you have to basically do printf debugging. Like, what's the process of going into a code base and figuring out, like, what the fuck? Well, how does this work? What are the flaws? What are the assumptions? You have to like reverse engineer what all these other engineers did in the past, and the mess across the space of months and years, and you have to figure out how all that works in order to make improvements.
The reason why I've always just been good at printf debugging, because one of my first kind of side quest jobs that I got was writing robots for the government when I was still at school. And so I'd kind of do this contractually for so many hours a week. And my boss, Hunter Lloyd, great professor, by the way, he just said, hey, here's your computer. Here's the robot. Here's how you plug it in. Here's how you run the code. Can you write the flash driver, the Ethernet driver? Can you write the planetary pancake motor? Here's some manuals. I'm missing some. Just figure it out. I'll be back. So that was government work for me. So I was like, okay, I'll figure all these things out. And I figured them all out. And the only way to really get anything out of the machine was to print. And so it's like I had to become really good at printing my way through problems. And so that kind of became this like skill, I guess, I adopted, is that I can just kind of printf debug my way through a lot of these problems. Obviously, I'm not a game developer, probably a different world. Probably should use, I think John Carmack was on here and talked how great the debugger is. Different world. Because when I was at Netflix, there's machines that exist somewhere where on AWS, I'm not logged into them. I don't even know how to log into them. I'm not even sure if I have credentials to log into them. They run once somewhere, and I have to figure out what happened and why it's happening. So it's like, I'm going to become... This is what I've trained for. Yeah. I'm a printf debugging champion. So it's just like I could just run through these things really quickly and figure out why they're happening the way they're happening.
You're a special human. I think that's an incredible skill set to have, to be able to drop in into any code base, to drop into any situation and do printf debugging, meaning like, you're in a dark room and you're feeling around that room to try to figure out what the room is.
Well, I had the code, so it's like I can kind of blueprint what's happening. Like I don't understand the services or anything that's happening, but like you can start guessing pretty quick as to what's going wrong.
Right, but then the print side of that helps you confirm your intuitions, test your intuitions, and build up more and more information, and then you start to accumulate like this bigger picture from that. What the edge cases are that break the system and not. I mean, I think that just that kind of space, like that kind of situation, is intimidating for a lot of engineers. Like they break down at that point. I think this really is a powerful thing to be able to come into a code base. That's generally a skill set of like very few of us start from scratch.
Yeah.
And actually, this is the fundamental problem of web development and in general, where they're like, I don't know what's going on. I'm going to write my own thing from scratch, right? As opposed to like actually doing printf debugging on the space of languages, on the space of problems, because there's a lot of wisdom and solved problems already in this code base. It's a much more important skill set to understand, to learn from the mistakes and the wisdom of the past, of the ancestors that came before, and build on them, as opposed to throw it all out and start from scratch. This is something obviously you see a lot with a JavaScript framework that comes out, a new one every single day. So
I have a very great story about that. That this is what I think has shaped me the most about my perspective of other devs. There's this dev, and he always just wrote things in just what I thought was such a bizarre and weird way. And this had to do with Falcor, so our data fetching library for Netflix. This would run on mobile, so I had to write in Objective-C. It had to run on television, and it had to also run on web. So it ran on everything. And it was me and one other person were responsible for this thing working. And the request side, where we'd have to dedupe the information that we already have, the requests that were pending, and the new data. So I had to figure all that out based on what someone's requesting, and then just only optimally request the stuff that we don't have. He wrote it in such a goofy way, and I'm thinking, man, this guy is just, what a goofball. So I delete it all, and I start writing, and I'm like, look at how much nicer this is. It's looking so good. I'm like, ooh, there's that one edge case. Okay, I can see why he wrote it this one way. That's not a big deal, though. The rest of my code's really great. By the end of it, I'm like, I literally almost line for line just reproduced what he already wrote. It's like slightly different towards my style, but I just wrote the same code. And I'm like, I'm an idiot. I am the idiot in this situation because it was already a solved problem. I just didn't take the time to learn what he did. Instead, I relearned what he did by rewriting the entire thing.
I think that's a skill set that is extremely important for people to learn. I see that in myself. That's a constant struggle for myself. When facing a code base, for example, but this applies generally in life, where somebody did a lot of work to do a thing, you should invest a huge amount of time and get really good at figuring out what they did, why they did it, do a lot of printf debugging to understand what they did. It's a much more efficient way to understand a problem deeply than to start from scratch, even though there's a constant temptation to start from scratch, because starting from scratch is fun. You do get the puzzle solving, all that kind of stuff. It's just not going to be the right thing to do. Usually pain is the right thing to do, and it is for most people painful to understand other people's code bases.
I highly recommend starting from scratch if you want to understand a concept. You don't know how an HTTP server works? Create a TCP socket, learn how to parse HTTP. It'll become very easy, and you'll go, this is the reason why whenever I get a request, I have to await the text. I now understand why the text is, for whatever reason, not there. I get it. I now understand it. And so you kind of gain these new perspectives just by simply parsing something out.
All right, back to the wisdom of Reddit. Apparently, there are memes and legends about your programming arc in Netflix. This Falcor system you mentioned. Somebody, I think it was Tej. How do you pronounce his name, by the way?
Tej.
Okay, Tej.
It's TJ would be his name, but we call him Tej. Or Telescopic Johnson.
Oh, wow. So many names. DDoS, distributed denial of service attacks. You apparently were able to accomplish the simplified version of that, of just DOS. That's a legend. So you basically broke down the system somehow.
Yeah. So
can you tell the story of that?
I'd be glad to. So this Falcor. So there's this Falcor business, right? And I did discover the bug before anybody else, and I did report it to security, and it was so bad. It actually got its own name, repulsive grizzly attack.
Yeah.
And they even give examples of how to do it. Effectively, what it means is that there is a request that targets both memory and CPU and will destroy. There you go. Look at that. How Netflix. The next one down was the article that was actually written. Yeah. I don't get mentioned, which is a little bit upsetting considering I was the one that discovered it and told everybody how bad it was. Anyways, and had to write the fix for it, or the first fix. So this is how it works: is that you can do something pretty similar, I believe, with GraphQL as well. It has the same kind of danger. Any of these kind of RPC, request as much or as little of the data as you would like frameworks, are vulnerable to this kind of attack. So with Falcor, what you do is you give it an array. An array is called a path, and that's the path to the data. But sometimes you don't want you don't want to have to write out, I want row 0 or list 0 or row 0, column 0 title. I want row 0, column 0, description. I want, you don't want to have to write out all that.
Mhm.
So instead, you could just be like, I want rows 0 through 10, columns 0 through 10, titles and descriptions. So you can write in a very compact, nice little format, and it'll give you all that data. It'll go to the server will fill that all in and give it to you. Oh, dang it. List 3, it only had 3 videos in it. So what happens when I try to re-request the data? Well, I need a way to be able to tell my system that you'd have requested the data and there's nothing there. So this is called like they call this like a boxed value. So it's going to be like type something, value, there's nothing there. We've already requested it and there's nothing there. They call, it's like a sentinel value, if you will, a boxed value. And we have this little special flag we'd pass called materialize, meaning that when you ask for a path, we will make sure we fill it out so we don't accidentally erase anything. And at the very end, we'll say, okay, the request you've made has already been made and there's nothing there. Well, what happens if I request rows 0 through 10,000, columns through 10,000, one more item through 10,000, and then a whole bunch of properties, and then ask it to materialize? Well, I'm about to go create billions of objects in the JVM, and what happens to the machine? It stops running. And then if we try to JSON, even if it could create them all, we then ask it to JSON serialize. It's not going to do it, right? Like it's impossible. And so that was the attack vector, is a simple while loop would have taken down and held down Netflix for a very long time because one request would kill one machine on AWS. And so that means it would just turn it all off. And this was on the website. This was on TV. This was on mobile. Like this was profound. And here's the worst part. It was in production for years. So we couldn't even roll it back. There was no like, oh crap, let's just roll back to 2 weeks ago and we'll kind of fix forward and figure out. No, it's like we could roll back to 2011. Like that's our option is 2011 and that's it. So we had to figure out a way forward and all that. And so it was like the amount of problems that would have happened if someone would have discovered this is unstatable.
Just to be clear, the infrastructure that's serving the videos would shut down.
Yeah, the UI, like you couldn't perform any actions on the UI. You surprisingly could still stream video, but you would never be able to get to a video to stream because every action you would take would be completely shut down. And so it wasn't a DDoS because you didn't need a bunch of computers to try to overwhelm the system by making a bunch of requests. One request, one machine. If we had 50 machines serving the millions of requests, it'd only take 50 requests to shut down the entire UI.
Isn't it possible to do DOS or DDoS on basically any software system? Like defending against all the, closing all those attack vectors is probably really difficult. If you take any sufficiently complicated software system, there's probably so many ways to overwhelm it.
Yeah, this is why people use Cloudflare. I think DHH said it best, which is like, we have our website and we have a strong bodyguard on the outside. So Cloudflare has a bunch of utilities all built in because, obviously, this is why everyone hates all these Bluetooth devices that connect to the internet because they just turn into attack vectors where people use those to DOS or DDoS other sites. And so you don't need something sophisticated. You just need a bunch of requests to come in and you can take down websites. And so that's why these fronts are really good at kind of discovering where these problems are. But DOS is a bit different because it doesn't have to be overwhelming by using resources with a whole bunch of requests. It really just means simply that there's a denial of service attack. One of them could be, there's a regex attack that existed where Cloudflare actually did it to itself and shut itself down, which is there's a regex expansion attack where given the right kind of regex, if you know someone's running a specific regex, you can actually provide input that is maximally bad, and that thing goes to like super processing. It takes 10 seconds to process a single request. Then you only need to make hundreds of requests and you shut down the whole service. It's not like you need some giant machinery to make 1 trillion requests. You only need just some small amount to completely destroy a service. And so the web is an extremely difficult place to do it correct.
This is super fascinating. I do also wonder how many ultra competent, black hat hackers there are versus sort of the good guys versus the bad guys, how many bad guys there are, and what is the distribution of skill set on the bad guy side that are constantly trying to attack?
I assume there's probably a huge number of just really simple ones, script kiddies, right? Just people trying to just do things. And then there's a huge amount of like social engineering that just goes in where hacking's done not with a computer, but just by,
Yeah.
one of the classic ones. Kevin Mitnick had this one in his book, which was you'd call up somebody pretending to be like, Charlene, we're doing some auditing, and I think your pin's out of date on file. Is it 2323 still? And they're like, no, it's 4747. You're like, oh, thanks, Sharon. Boom, you just hacked them, right? Like the classic. People love correcting bad information.
Yeah.
This is like a standard. So like there's all these ways people hack. And so my assumption is that there are really great white hat hackers. There's really great black hat hackers. But the vulnerability space, the thing is that discovering a vulnerability and you don't let anyone know, the white hat hacker still has to make that same discovery.
Yeah.
And that's where I think the real thing is that black hat hacking in some sense has a fundamentally easier job, or at least a job in which they can take advantage of for much longer periods of time. One's the process of discovering who's breaking the system. The other one's trying to figure out how to break the system. And it seems like most software is held together by toothpicks and glue.
Yeah.
And there is a lot of dangers in every piece.
And also the social engineering aspect. That's a real attack vector. I think that's the attack vector that will do, in the long term, the most damage in the world. Especially as AI tooling becomes easier and easier to convince people at scale, sort of do that kind of email grandma. I think that's a really serious attack vector, like human psychology and all that. I kind of assume whenever there's a girl that approaches me, it's kind of some kind of social engineering project, some attack vector, some intelligence agency. In fact, I'm pretty sure.
We're back to a beautiful mind, aren't we?
Beautiful mind, yeah. I have a whiteboard upstairs that I calculate everything, everybody's trajectory and move.
You're not wrong, though, with the attack vector, especially in the day of AI. Like, one thing that I don't think a lot of people are talking about as we integrate more and more AI is that prompt injection is like an extremely hard thing to defend against, because it's not really clear how you defend against it. If it's just at the end of the day, word calculator, make word come out. If you can figure out the proper word calculator input, it might just break its bounds and start doing something it's not supposed to do. And there's a whole future where there's all these products that are going to be vulnerable to things they never thought about. Like it's one thing where you forget an edge case while you're programming. Now you have to guess what people might be able to think of making something that has access to a system be able to do, right? And you don't have a way to reason about it. Its reasoning came from Reddit and other words that it's read and how to put things together. Like, this is it's a massive space that's going to be happening. That's why I'm personally thinking, don't give too many powers yet. Like, we don't know the attacks that are about to happen.